Welcome to my dear students. So today we are talking about the protection in PWM for complementary pulses. So always when we are generating the complementary pulse, we know it's why we are doing so, because in complementary switch, in case of inverter, for the complementary switches, if that two complementary switches are on together, then the input DC source will be shorted and the high current will be flowing, and the PN junction of the semiconductor will destroy. So we have to protect that, and it will happen it will happen instantaneously. So we have to do something so that once this condition occurred, immediately the controller should stop to generate PWM. So for that we will be using external hardware interrupt pin. So for that the separate video is available in my YouTube channel, where the function of external hardware interrupt and how it is to be configured for different modes, those are explained. So you can refer that video to understand in details about the external hardware interrupt. So as this is to generate around 25 kilohertz PWM for induction heating purpose, and also we should check the condition that the complementary pulse is not on together for any instant. So already that you know. So this is the code. So here you see one more function I have used, that is to configure the external hardware interrupt, and that function name I given external interrupt initialization. In that external interrupt initialization, what I have done, I have configured one interrupt pin. So for this particular IC, there are two interrupt. If you see the system means this controller architecture, so you see this is INT0 and INT1. Okay, so I am using interrupt 0. So based on that I have configured this bit. If you see that my video about external hardware interrupt configuration, you will understand it. And once this interrupt will, here I have configured it for raising edge. So once the controller will detect the raising edge, so it will redirect to this service routine. And in this service routine, what I am doing, I am making both the timer control register to reset. It is getting resetted so that the PWM will stop immediately. So this is the additional thing I have done. Okay, so now come to the circuit. So in circuit, you see here I have using one AND gate. It's a high speed AND gate. So definitely during the selection of the AND gate, you should see that the frequency at which you are generating the PWM, so the AND gate should respond at least on that frequency, or the operating frequency of that AND gate should be higher than the PWM you are handling. This is the criteria, and I am taking it directly from the microcontroller pin, but normally it should not be in this way. So these two pulses, it will be going to gate trigger circuit like TLP 250 or some other gate driver. So we should take in this two input of the AND gate should be taken from the output of the gate driver circuit, which is going to IGBT or MOSFET. Okay, because microcontroller naturally this kind of a malfunction will not happen. This will happen due to some hardware in the driver circuit. Normally, I am telling from the practice. So instead of taking directly in actual circuit, these two inputs should be taken from the output of the gate driver, and it is doing AND. Okay, and that is given to, you see, the interrupt 0 pin. So first let us see. So here I have given the duty cycle 50%. Both the pulse will generate 50%. So in that case, what will happen? Let us see. Now you see, if we run it, what will happen? Because it is coming in the same, when the raising edge is coming for the instant the raising edge is coming for non-inverting pulse, at the same instant the falling edge of the inverting pulse will be there. So naturally it will, for that particular instant, it will generate a spike. If that spike is generated, that means it is going, that input DC tends to become short. So once that raising edge is there, this AND gate is producing the raising edge, then immediately this interrupt is enabled, because that interrupt I have configured for raising edge detection. So immediately, so in code you see what I done, if that raising edge is detected, then both the timer, counter, control register I am doing reset, then immediately it will stop the PWM. So now let us see the situation. So now I am simulating it. You see, immediately one raising edge occur, this pink and PWM off. It is happening very fast. Okay, let us do one thing. This slightly reduce the scale. Yep. There is this one. Now again I'll run it. You see, immediately that pink color pulse one raise, and immediately the PWM goes off. Got it? Once again I am running. You see, your pink color is generating one raising edge, and immediately the PWM is getting off. That means this, both the complementary pulse is getting overlapped. Now here I will change, slight I will reduce, say 150. Now the sufficient, now the both the pulses will be not get overlapped. So now let us run. You see, now the pulses are, there is no problem. This pink color pulse, pink color output pulse, it is never becoming high. So interrupt is not enabled, and PWM start to continue. The timer is continue to generate the PWM. Okay, so hope this concept is, you have understand the concept. So this concept only I was trying to explain. Okay, where is the other channel? This is the other channel, and this is the another channel. Okay, so again I am showing you, if I am giving more, say it is giving 170, let us see what will happen. Now it is more overlapped. You see, suddenly that pink color pulse came, and after giving one pulse itself, after that PWM will stop. Okay, so for that, what are the things I have added? This one function I have added. It's a user defined function where I am configuring the interrupt. So for the to configure the interrupt, what I used, these are the two register I have set. Okay, and in the service routine of that, I am resetting the timer 1 control register. That means it is, the PWM is getting terminated. and in this way that protection is enabled. So I hope you have understood the concept. So now your assignment is to do the same thing as I told. You take the datasheet of the MOSFET and find out the T on and T off. So among these two, which one is higher, you consider that, and over that you take 20% margin. Then based on that you generate the dead time, and after generating the dead time you confirm that this condition is satisfied, and if there is no dead time, then also a timer is off and it is not generating the PWM pulse. Then after that we will go for the next. So hope this concept is clear to you. Thank you so much. Thanks for your patience.